Oxidation state. OS. Now what is the meaning of OS? It is the real or imaginary charge, real or imaginary charge that is associated with the atoms when it is present within the compound or molecule. For example, if we have taken example of NaCl, in the NaCl, Na becomes +1 and Cl becomes -1. So here is the +1 and -1. These are two real charge, and these two real charge are called the oxidation state. Here is the +1 OS for the sodium and -1 OS for the Cl. So we can see that if we take an example of ionic compound, then the charge becomes real, and these real charge is called OS of that atom. Similarly, if we have taken an example of HCl, it is a covalent compound, but due to higher En, the electron pair shifted towards Cl. So here is the Cl is delta negative and H is the delta plus. In this example, Cl carry negative charge and hydrogen carry positive charge, but this charge becomes called imaginary charge. In this example, OS of the Cl becomes -1 and OS of the hydrogen becomes +1. So we can see that if we take an example of covalent compound, then the charge becomes imaginary, and if we have taken the example of ionic compound, then the charge becomes real. Now we have discussed the rule for finding the OS rules. Now the first rule becomes OS of the hydrogen becomes +1, but in metal hydride means when hydrogen atom bonded to the metal, but in metal hydride OS of the hydrogen becomes -1. For example, if we have taken an example of HCl, then here is the OS of hydrogen is -1. But if we have taken an example of sodium hydride, in this example, hydrogen bonded with the metal sodium, so that's why it is called metal hydride. And in this example, OS of the hydrogen becomes -1. Sorry, in this HCl, the OS becomes of hydrogen is +1. And the metal hydride, the OS of the hydrogen is -1. And the second rule becomes OS of the first group element that is also called alkaline metal becomes 1. For example, first group elements are lithium, sodium, potassium, rubidium, cesium. All have OS becomes +1. And the third rule becomes OS of the second group elements means alkaline earth metal. Alkaline earth metal equals to +2. For example, beryllium, magnesium, calcium, strontium, barium all have the OS +2. And number 4th rule is OS of the halogen means fluorine, chlorine, bromine, iodine equals to -1, and the fifth one is OS of the oxygen equals to -1, but in peroxide equals to -1. For example, H2O2, hydrogen peroxide, here the OS of oxygen is -1. Similarly, in superoxide, OS of the oxygen equals to -1/2, and in ozonide, OS of the oxygen equals to -1/3. The next sixth one, if we have taken an example of any ion, ionic species like sulfate contain -2, carbonate CO3 -2, hydroxide -1, cyanide Cn-, in all of these species OS equals to their charge. OH equals to their charge. For example, OS of the sulfate is -2, carbonate is -2, hydroxide is -1, and Cn is -1. Now, by the help of each rule, we are finding the OS of the some compounds. For example, we have taken the example of potassium dichromate, that is K2Cr2O7. If we have underlined the Cr, now we are finding the OS of Cr. So when we are finding the OS of Cr, the remaining elements, that is potassium and oxygen, putting the En of potassium, as we know that OS of the potassium is +1, so 2 into +1 plus, here is the chromium is 2 times, so 2x plus OS of the oxygen is generally -2, that becomes 7 into -2 equals to 0. So by the solving of this equation, 2 plus 2x minus 14 equals to 0. There is the 2s equals to 12 and x becomes +6. So we can see that in this example, that is potassium dichromate, OS of the chromium becomes +6. Now we have discussed another example KMnO4. In this compound, finding the OS of manganese. Now potassium is +1 plus x plus 4 into -2. OS of the oxygen is -2 equals to 0. By the solving of this equation, we get 1 plus x minus 8 equals to 0. So x becomes +7. Now the next another example, we have the example of H2SO4. Now finding the OS of sulfur. Now the OS of hydrogen becomes +1. So 2 into +1 plus x plus 4 into -2 equals to 0. Now 2 plus x minus 8 equals to 0, where x equals to +6. So we can say that in this example, OS of the sulfur becomes +6. Now another example HNO3. In this example, finding the OS of nitrogen. So OS of the hydrogen is +1 plus x plus 3 into -2 equals to 0. There is the 1 plus x minus 6 equals to 0. So x becomes +5. Now we are taken up example of lithium aluminum hydride. In this example, finding the OS of aluminum, lithium is +1 plus x plus, in this example OS of the hydrogen becomes -1 since hydrogen is bonded with the metal. 4 into -1, it becomes 0. Now 1 plus x minus 4 equals to 0. So x becomes +3. In another example, if we have the example of potassium ferrocyanide, K4FeCN6. In this example, finding the OS of Fe. Now potassium is 4 into +1 plus x plus OS of the Cn becomes its charge, that is -1. So 6 into -1 equals to 0. So 4 plus x minus 6 equals to 0. So we get X equals to plus 2. Now in this example, OS of the iron becomes plus 2. We are discussing another example. For example, if we have taken example of glucose C6H12O6, it's the formula of glucose. In this formula, if we are finding out the OS of carbon, then 6x plus 12 into plus 1 plus 6 into minus 2, it becomes 0. Now 6s plus 12 minus 12 equals to 0. So 6s equals to 0, x becomes 0. Now in this example, OS of the carbon becomes 0. Now if we have taken up example of H2O2 hydrogen peroxide, finding the OS of the oxygen. Now hydrogen is 2 into plus 1 plus 2x equals to 0. There is the 2x equals to minus 2 and s becomes minus 1. Now if we have taken the example of O2F2, in this finding the OS of oxygen, now 2x plus 2 into minus 1, which halogen, its OS becomes minus 1. Now 2x minus 2 equals to 0. So 2x equals to 2, x becomes plus 1. So we can see that in this example, OS of the oxygen becomes 1. Another example, if we are finding out the OS of oxygen in the H2SO5, is also called persulfuric acid. If we have drawn the structure of this compound, then we get that sulfur, OH, there is the OH, is it, and is that 1, 2, 3, 4, 5. In this example, these two oxygen are called peroxide. Peroxide oxygen are those oxygen which are bonded with the OO. Now in this example, if we are finding the OS of the sulfur, then according to the structure, hydrogen is 2 into plus 1 plus X plus. Out of 5 oxygen, these 3 oxygen, that is 1, 2, 3, which minus 2. So 3 into minus 2 plus. These 2 oxygen becomes minus 1. So 2 into minus 1 equals to 0. Now the solving of this equation, 2 plus x minus 6 minus 2 equals to 0. So 2 plus x minus 8 equals to 0. Now x equals to 2 plus x minus 6 minus 2 equals to 0. Now 2 plus x minus 8 equals to 0, or x equals to plus 8 minus 2. So x becomes plus 6. So we can see that in this example, OS of the sulfur becomes plus 6. We can find out the OS by the help of structure. For example, if we have drawn the structure of H2SO4. Now in this structure, sulfur OH. Now OH, again double bond with the oxygen and one more double bond with the oxygen. In this example, En of the sulfur is more than oxygen and En of the oxygen is more than hydrogen. So in the sulfur oxygen single bond, the oxygen becomes minus 1 and sulfur becomes plus 1. Similarly, in this side, oxygen becomes minus 1, sulfur becomes plus 1. In this side, oxygen becomes minus 2 due to double bond and sulfur becomes plus 2. In this example, oxygen becomes minus 2 due to double bond and sulfur becomes plus 2. Now total plus charge around the sulfur becomes plus 6. That's why OS of the sulfur in this example plus 6 and the OS of this double bonded oxygen minus 2 minus 2. Now our single bonded oxygen minus 1 is due to the sulfur. Now if you have discussed from hydrogen side, then O single bond H, hydrogen becomes plus 1 and oxygen again minus 1. So OS of the oxygen becomes minus 2 and in this hydrogen becomes plus 1 and oxygen is minus 1. So oxygen becomes minus 2. So we can say that the OS is also find out by the help of structure of any compound. Now if we have to take another example of if we have the example of CH4 finding the OS of carbon. So X plus 4 into minus 1 equals to 0, X minus 4 equals to 0, X equals to plus 4. That is the OS becomes plus 4. Another example if we have CCl4 in which carbon tetrachloride finding the OS of carbon, and X plus 4 into minus 1 equals to 0, it becomes X minus 4 equals to 0, X equals to plus 4. We are finding the OS now. HCl4, it's a perchloric acid, finding the OS of Cl. Now the putting of value hydrogen plus 1 plus X plus 4 into minus 2 equals to 0. 1 plus X minus 8 equals to 0. That is the X equals to plus 8 minus 1. So X becomes plus 7. So we can see that in this example that is called perchloric acid, OS of the Cl becomes plus 7.